Hello, welcome back to BLENDERSUSHI live noding. Today we're gonna cover another basic stuff. It's a basic concepts of computational thinking. So it's when you this is really for beginner, and if you're really you want to do some programming in Blender, but you are not quite sure why you want to do programming, but this is like a live noding video, so I think I cannot try to focus on many things, and I'm gonna actually use this Wolfram Programming Lab as my kind of like a guidebooks to understand the computational thinking and how you think about programming, at least how I think of programming in Blender. So this is Wolfram Programming Lab, right? I play around with it a little bit, especially with the free versions, with the Wolfram Cloud and Wolfram language. Not the paid version of the software, but I like the idea that they have, being able to just go to the cloud on the computer or on the iPad or on the iPhone, and just type in some of the functions and expression that's given by Wolfram language. It's quite interesting. It's really can take you quite far and create some interesting thing using the provided algorithm. I think there's something here that we can learn, and we can port it into Blender and doing noding and stuff. So let's try this one of the basic example. Draw a sphere in a Wolfram. So in Wolfram, in order to draw a sphere, you need to run these functions, graphics, 3D, and then inside this function you have another function called sphere 3D, and obviously sphere, this sphere and the bracket will actually generate the sphere. We don't know, we don't care about the radius or the color at this point. Just make a sphere. In Blender, if you want to make a sphere, if you are doing it manually, obviously you go to create. You can, okay, you know that you can select one of these, and then in this case we want to have a sphere. So we have to find a sphere. Where's the sphere? Plane, cube, UV sphere. Okay, this is sphere. Click and you got a sphere, and you have these options for the segments, for the rings. Maybe just make it 8 by 8, the size in radius, in Blender units, and we can set it to align to view if you want, generate UV, and so on and so on. So that's you generating one sphere. If you want another sphere, depending on the position of this 3D cursor, you place it, and then you click on this guy again, and okay, that's another sphere. We can change the radius so it's not so boring, and create another one, and so on and so on. Now if you want to do it using Python script, how do you do that? You probably already know that some commands in Blender, you can just look at the history and then get these functions and then use it in using Python. So let's actually do that. I'm gonna switch to the Python console, and I'm actually gonna have the text editor as well. So we're gonna be using Python scripting to do that, to do this thing. I'm gonna put the 3D cursor somewhere else, and then I'm gonna run this command, ppy.ops for operators, and then mass primitive UV sphere add. And you see, this is a function. This is one of the Blender Python functions to create a UV sphere, and here we have the parameters. We have the size in red, in the which means it's the radius of the sphere, and then the view align, just like the option that we saw earlier. And then we also have these locations and then layers. By default, it's true in a, which means it's gonna put it in the layer 1. The rest of them is false, 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 false. There are many of them, and then it makes the commands really long, but we don't actually need to type all this if you don't want it. It's gonna make the default anyway. So let's say we want to make a sphere with a size of 0.2, and then the locations, actually we can specify it, or if we didn't specify it, it's gonna put it on the 3D cursor. So if I run that, it's gonna generate a sphere. Okay, that's cool. That seems to be pretty clear enough, and you can actually run this multiple times. And the reason you want to use script maybe is if you want to generate a lot of this sphere. Let's say this is your script. We're gonna use we're gonna import the Blender Python module, and then because we need that in order to run this code. Let's say we want to have like 10 of this. We can type it like that, and then place the 3D cursor in here, and then make it make the size different depending on this number. So we're gonna have like a sphere with a radius of maybe 0, 1, 2, 3, 4, 5. Let's have a look. So currently, I'll delete the rest of the sphere, start from nothing. If I run the script now, okay, so it is generating some sphere, and then it's generating 1, 2, 3, 4. The first sphere seems to be has a 0 radius, and then the second one have 1 unit. Let's check it out in the dimension. So first one 0, 2, 4, 6, 8, 12. Last one 18, which is interesting. I was expecting to have like a 0, 1, 2, 3, 4, 5, and so on. So this is probably one way, one of the reasons why you want to learn some programming language. That's if you want to make like a multiple sphere. But let's continue with this, and then in Wolfram, the next lesson is just like set the color of the sphere. Okay, in this case, let's make it like yellow sphere, for example. Run the command. It's gonna make a yellow sphere, and then you can rotate it in Wolfram. And let's have a look at the next one. Oops, actually super slow at the moment. With the next one, make the sphere transparent, and in this case graphic 3D and the sphere actually have this kind of parameter that they can set for the color and the opacity. And in Blender, in order to do that, you kind of have to use the material, and that's something that you can do it manually. But if you actually use program like a Spreadshop or animation nodes, you can set it up very easily using nodes. So that's kind of my way of thinking. So if you can do it using nodes faster and easier, and it's something that you can do over and over again, maybe it's a good idea to use nodes anyway. So it's kind of like a little program that you encapsulate into the nodes. So okay, we have this sphere that we generated using Python script. and currently their material is, they don't have any material. So in Blender, in order to apply material, of course you select a single object, for example, and then apply a material to it, and then once you have the material you can give it a color. So this is how you do it in Blender in 3D. Of course, you probably already know that, and if you want different material for each object, you can do that, but usually the way to do it is to use a single material, but you want to use a different color per object, and you turn on the object color. And this is really cool, because now with this guy on object color, we can go to the object color and then change the color here. And by doing that, if now if I select all these objects and then select this object last, Control L, I can kind of make a link to the material, so everyone is using the same material as this guy, but then each one of them now can have different color. Okay, I can set up manually. So this is how you probably do it in most of 3D package. It's quite normal to do that. If you want to change the object color using Python, you can do that as well. It's actually quite easy. You see this bpy.context object color, and you have this RGB and then the alpha value. You can actually just try doing that. So I'm gonna save this. This is gonna be like a Wolfram inspired tutorial 001. Let's try changing the color of this. So, but instead of using the BPY, I think this is what confuse people sometimes. With a bpy.context.object.color or whatever context, that's really depending on what objects currently active. We can actually use the context, I think, if we want, but it's better to do it another way. I'm gonna show you real quick. So this is using the context. I'm gonna make this maybe black color, 000, or red. Let's do it. Okay, so I just made it red color for these objects. We can change it to another color like green here by doing that. So whatever objects currently selected, I can turn it green if you want using this bpy.context. There is another way to do this. bpy.data.objects, and then kind of let's pick like a random sphere and then kind of go to its data, and okay, it's actually the color. So if I'm using Python code to change the color of sphere number 5, I can do it this way. Make it red color. So that's sphere number 5. So I can change it quite easily that way. So we can say, if we use bpy.data, is there like selected bpy.context selected objects. Okay, bpy.context.selected objects. This guy will select all the objects. So this is pretty useful. Then I can just copy this and then put this in here. So now I can say, okay, this is the obs. I can say for every object in OBS, for the object color, just make it all red. So I need to specify this for value RGBA, and if I run this, see it works. I can make it red and green, yellow. So okay, so that's doing it using Python. I know only like the basic of Python's, the one that I can remember from top of my head. But of course, you can with Python you can also like make a random value for the red, random value for the green or the blue. You can do all that. It's quite easy. Now, if we switch to the node-based way to do this, how do we do that? Let's try. I'm gonna select all these objects and then group it. If I'm using animation nodes and objects group, and then this is how we actually do it. Select this guy, select all these objects in this group, and then I'm gonna tap W and then gonna loop through every object, kind of like what we did with using Python here. So grab, get some selected objects or something, and then for every object in the selected objects, change the color into this color. We're gonna do the same thing. Combine color. And there is also color input. And objects attribute output. So for every object here, give it a color, give it this color. And this is the attribute, just specify it color. Now every single sphere is red if we want to make it red. So this is like super basic, but this is kind of important if you first time use a node-based system to make a colorful sphere. If you want to actually specifically select an object, you can do that using objects input, I believe. So object input, and then do it this way. So let's say I'm selecting this guy, plug it in, and give it a color. Hopefully it works. Okay. Now I'm changing the color just by using nodes. So it's almost like kind of like a playing with like a toy of you have all these nodes to do that, instead of having to go to here and then changing the color here manually. You can do it using nodes. So it's just like all this is just like an option for you, but the nice thing is, of course, when you're dealing with many objects and you want to make a quick changes, okay, let's make the color like a rainbow color, or with a random red, random green, or random blue. You can do that really easily by using random number with a random seed. This will generate random number between 0 and 1, and plug it, and you have random red color. If I zero this out, I get this. Some has more red, some has less red. With the alpha, we cannot really see it unless we turn on the transparency. So more green and blue. We can have a random green, red, green, blue, and we have a grayscale currently. But if we randomize the seed, we have random number, random color. So you will see randomize the seed, and then things started to look more random. Okay, that's pretty basic. There's actually one more thing. It's with generating a sphere. Okay, currently animation nodes doesn't have ways to generate objects, but it has a cool thing called object instancer. This is usually how I'm doing this. Let's say we want to have like a torus. So this is the master torus. I'm gonna grab it, and then how many of these torus we want? Maybe make it 10. So now we actually have 10 torus. They are all in the same spot. Plug that in. Okay, now for the torus, let's say we want to have random color. This is already random color already happening actually. All we need to do is just select this guy and then give it a material, turn on object color, and then Control L, make links material to all of them. Now, of course, they are all in the same spot, so we can't really see what's going on. So the next thing we want to do is to use the object transform output here, and for each object you can randomize the location, random vector, plug that in, and now we have all the torus in a random position. Yeah, I think that's pretty cool. That's a one way to do it, because like I said, animation nodes doesn't have nodes that generate 3D objects yet. Actually, I lied. There's a few generator here. Line and grid. You can generate line and grid procedurally in using animation nodes. But if you want to really generate objects, you can use Sverchoks for that. So again, I'm gonna delete all this. Gonna save this real quick, because Spreadshop is another node-based add-on, and with this guy you can generate a lot of things. See, n-gon, box, cylinder, sphere. Let's do a sphere. Okay, sphere in Spreadshop. And with Spreadshop you have these viewer nodes, viewer draw nodes. You can see this kind of ghosted version of the objects. It doesn't render. This is just like a Spreadshop thing. Let's make real objects. For real objects we use the bmesh mk2, and if I plug that in, and now we have real objects, and that's how we can generate sphere using Spreadshop. And then for the transformations we can use this matrix and the vector for the locations. So this is like a complete creations in Spreadshop. This is one way you can do this. If you want to have a multiple sphere in Spreadshop, you can do that quite easily, and maybe use random vector. So instead of a single position, you want to have maybe 25 of this sphere, and then randomize the position. Currently, because of this random vector is generating everything kind of like in the surface of another like invisible sphere. We could actually use a randomize input vertices here, and then just add more randomizations. So that's just a quick trick to do that. And if you check in the outliner, Sverchoks actually generates some objects there. It's called alpha. By default, this thing generates, it's using alpha as the name. You can group them, and by grouping these guys, you can easily select them and then Shift G and then select them as a group. I like this kind of workflow. I think it's highly recommended. So once you have this in Sverchoks, you can actually assign it a material, for example. In this case, I'm gonna create a new material and this guy with a object color on, and gonna update. If I update it, I believe it should update all this guy, and applying the material, if I select it, okay, I need to select it right here. So that's our material. It's been grouped. Sometimes you want to merge it, but in this case we want them as a separate objects. Once we have this, and then we can go to animation nodes and then select our group and then plug this to that guy, and then magically our things works nicely. So we have this random color for our objects, and if we really want, we can change the scaling in whether using animation nodes or using Spreadshop. So this is kind of workflow that I recommend any users of Spreadshop and animation nodes. If you use this for the first time, and this is kind of a nice clean way to do it. So generate the mesh using Sverchoks, and then do like the material things using animation nodes. But after a while, you can use either way. Let's say you want to change the scale of these objects randomly. You can use a random number generators. We need 25 number. Okay, and then we use the vector in for the scale, and then we just plug this guy in, and hopefully we have randomly scaled sphere and randomly placed, and then also they have all random color because animation nodes kind of doing that as well in the background. So this is quite nice system. Definitely super basics, but yeah, that's pretty much it for this live noding. You will see there's also like related tutorials in Wolfram Programming Lab, like this circle scapes. In this case, it's one tutorial that teaches you how to use Wolfram language to generate a random circle. The idea is actually the same here. See, it's using a random real. So there's these functions that's generating the random value for the circle radius, and it's gonna generate random color and random opacity, and it's doing it by using all these functions. There is another program tutorial down here that's currently, my Safari is really slow, but there's another tutorial that I think is really nice. It's this one, color cubes. If you want to generate like a cube, like a 3D grid of sphere with this RGB color, you can have a look here and then generating it using Wolfram language, or you can also just use a Blender Python, or you can use it. You can use node-based system like this. I think it's a kind of like a really nice, really rich environment. You can actually go quite far. Like I found that even myself currently is maybe kind of like intermediate, in the intermediate level. Still, sometimes I need. I'm digging the programming language at the moment, like Python. I think once a person can do it using nodes, it's much easier for that person to kind of type it using programming language like this. It's everything is kind of related in the funny way. Obviously, if you want to write a program that can generate like 100 sphere, for example, like using Python, you can easily do that. But I found it's kind of I don't know, I like to do it using nodes, but nodes is really it's not so much of programming, but there is some kind of programming concept that you need to understand, like a computational thinking, whatever they call it. All of them can help each other. Like here with Wolfram, okay, Wolfram, the cool thing about Wolfram is it's like this guy has like this language has a lot of knowledge, basically like lots of algorithm, and it also has a lot of they call it knowledge base. So it's like a really huge library on everything, including like you can ask Wolfram, for example, give me like 100 different types of birds, and it will give you image of birds, 100 different birds. Of course, you cannot do that using Blender. Maybe you can sort the image from internet first, and then kind of categorize it, and you know, with Wolfram, this thing actually quite interestingly can it has its own library. So if you can say in Wolfram, okay, give me the last 30 presidents of United States, and then sort them by age, and sort them, and then give me the information of the date they are being born, and then the city they live on, and then etc. etc. It's a Wolfram is interesting in that way, because it's like what do you call it? It's like a Google, but a program. You can program it. You can program all this knowledge with Blender. If you want to do that, you can, but you probably need to. You can program it using Python, and then try to classify all this kind of database of informations. But my biggest interest is kind of to work with data and kind of to visualize it in an interesting way using Blender eventually, and also using nodes makes everything easy to follow and to tweak as needed. So I guess that's the whole idea. I'm not. I wish I have the Wolfram app, but it's really super expensive for a license for Wolfram. But you can always go to the Wolfram cloud and play around with it for a bit. Like, see, you can play around with a map, and then there's an algorithm how to find the shortest path, and there's this Wolfram dealing with text, and Wolfram also can understand the text and stuff. Not so much with visual, but this algorithm thing is very interesting. And this one, random alphabet, I think with Wolfram you can also do like a neural kind of, what do they call it, neural network. You can teach the computer to learn kind of a hand drawing. It's trying to do a lot in one using one tool. That's Wolfram. But anyway, I think some of the lessons here are worth looking into, and then if you understand that and then try to port it to Blender and Python and nodes, it's somewhat my dream to do. Okay. Anyway, that's all for this live noding. Hopefully you'll get something, even though it's basics. Try doing this and get familiar with it, and that's a good starting point, I guess. If you have any question, feedback, suggestion, just let me know down below, and I'll see you in the next video.